Hi everybody, it's Mrs. Williams, and today in this video I'm going to walk you through the website you're going to use to build your Clawbot this season. Now, first of all, we would like to welcome you all to the TUSD Robotics program. We're super excited to have you join us, and there's many more opportunities down the road to do robotics at the Tustin Public Schools Summer Academy program or in middle school or high school. So welcome to the program, and we hope you stick with us for a long time. We want to thank the Tustin Public Schools Foundation for not only fundraising and supporting our programs and hosting tournaments, but also for helping purchase all of the kits that you are going to use. All right, so let's jump into some things on this website. First of all, you're going to find many different parts in your kit. And this poster is very important to use to identify the different parts. Now, if you have a direction page that says you need this part, and this part, make sure you go up to this poster. It has its life size, and you can match the beams up to make sure you have the correct part before putting it on your robot. If you don't check and you put the wrong part on your robot, it's really hard to figure out if you go several more steps in the directions where the mistake was made. So just be safe instead of sorry, and check to make sure you have the right part before putting it on your robot by checking either the product number or the name on the poster compared to the directions. Now, if you want to learn more about VEX parts, here's a VEX parts website that goes through the 3 different categories of parts: the electronics, the motion, and the structure. And you can kind of see the motion would be the gears, the structure would be all these beams, and here's all your electronics in the pink up here, which are your wires and your sensors and your batteries. So they've also divided it up on the poster by color. All right, at the top of the poster, you will see that there are some building tips and tricks, but I'm going to walk you through this right now using this slideshow. So first of all, you will see that sometimes the gears, especially the small ones, are a little bit hard to get onto the drive shafts. So this drive shaft or axle is what goes into a motor, and it also goes into a gear or a wheel, so it turns. So it's much easier if it's kind of hard to get on and it's hurting your fingers to use another beam, push that beam down and leverage it and pull the beam down and push the gear instead of using your fingers. Another tip is that if you get a pin stuck in the top of a motor and it's hard to get out, you can use a beam as a tool. Snap it onto the pin and then turn that beam and it will pop that pin out. The next one is if you have pins that are stuck in a beam, you can use another 1x beam to pop it out and just get that tip of that beam and press it against the back side of that pin, and it will pop out just enough for you to use your fingernails to take it out on the other side. You will also find that these corner connectors can sometimes get a little stuck. So you can use a drive shaft or an axle, slide it into one of the holes, and then lift it up like a crowbar and pull out that corner connector. You will also find that the shaft collars can be very hard to put on when they're cold. So all you got to do is put them in your hand, heat them up, and then they slide right onto that drive shaft. The last tip here is to make sure you use that poster to compare the different beam angles. These are the 3 most confusing parts that students confuse: the 30-degree angle, the 45-degree angle, and the 60-degree angle. If you just look at them, they look very much the same, but actually they make a big difference if you choose the wrong one and place it on your robot. So just use that poster and make sure you have the right parts that are mentioned in the directions. So let's head down and look at this tool. Instead of using the beams as tools, there is a new tool that's a pin puller, and you squeeze it and you're able to pull out the pins. You can also use these little dots at the end to push out pins. So if you're interested in purchasing these, you're just going to go to the VEX Robotics website right there. All right, let's talk about the robot you're going to build. I'm going to go ahead and click on this link at the top, a new page. We're going to build this robot that you can see in the top left corner. It's called the Clawbot. I'm going to scroll down a little bit and you will see here's a much better picture of it right here. And you're going to drive this with a remote control, and this arm is going to go up and down, and this claw is going to squeeze together to move blocks around on the game field. So here are the directions to build the VEX IQ Clawbot. It's a long PDF file. You can open it up on your iPad, or the paper version does come in the VEX IQ kits, and you might actually still have them in your classroom. Now, it's very important that you stop at step 87 because we're not going to add any sensors. The sensors will have a problem with your joystick when you're driving. There's also a sensor that gets added at step 32, but you're not going to plug this in step 34. Just leave the cable out. You can put the sensor in, just don't plug it in. So we're not going to add any sensors. Now, if you get stuck on a step, let's say step 23 is confusing in the directions, you can use any of these links to show you the animation. Let me click on step 23. Here you can see step 23, and I'm just going to play on that animation. You can see this is how it's going to be put together. So you don't need to use these animated steps. They're just there to support you, but all the directions you will need to find are in this link right here. All right, let's talk about the reason that we are building this robot, and it is to play this game. So the game is called High Rise, and you're going to move the blue blocks and try stack as high as a stack as you can on the blue goal, and the green on the green goal, and the red on the red goal. Now there's a couple ways to play this, and you're going to watch this video right here to show you about the game, but it's going to explain 3 different ways to play: programming skills, teamwork, and driver. Now for our own program, you probably will just want to do the driver competition. If you do the driver competition, you will have Team A play against Team B, play against Team C, play against Team D. And you're just going to probably give about 3 tries and add up the points for all 3 tries to see who gets the high score. Now, it's very important that you read the game manual, or at least the coaches do, to understand the rules of the game. Most importantly is that you have a 1-minute driving period, and that joystick needs to be passed to the other driver between about the 25-second and 35-second mark. So 2 drivers will drive for each challenge. So in game 1, you might have your first 2 players drive. For game 2, you might have your other team members drive. And for the third game, you might choose your best drivers for the third game. So you can really, because this is not an official competition, you can create your own rules, but there is a game manual right here for the coaches to look at all the official rules. Now, if your team is really fast, you might actually end up being able to use the engineering design process to modify your robot, because the Clawbot can only do so much and carry so many of the cubes. So maybe you will use this engineering design process to help innovate and improve your robot. We ask that you document each of your steps in an engineering notebook or composition notebook. And if you want to know how to do each one, they're all written out for you. So in step 1, you're going to define the problem. You're going to write down what you're trying to do with the game. Step 2, let me move my face over here. You're going to brainstorm some ideas. Step 3, you're going to research using some YouTube videos. Now, these are pretty advanced videos. You probably won't be able to do what they do because you would have to rip your whole robot apart. And you most likely don't have enough time to do that. But you could improve the claw to try and carry more cubes in at one time. That seems pretty reasonable. Now, then you will develop an idea. What are you going to do? And choose the one idea you're going to do. And then you're going to try and build it. So then you're going to build and test it and keep improving. And all of this will be communicated in your notebook. Now, remember, you also have to be ready for the showcase game day. So if your design is not working, you'll need to quickly turn it back into the Clawbot to make sure you have a robot to play the game. All right, if you run into any problems along the way, please go to this troubleshooting page right here. Now on the troubleshooting page, you're going to see some common articles on how to troubleshoot the brain, how to troubleshoot the motors. Here's a flow chart. All the lights provide information about what's wrong with the joystick or the brain. So this is all here for you to try and troubleshoot. This app right here, the VEX OS app, is something that your teachers will download onto their computer to help, I call it the doctor app, the robot doctor app, to help diagnose what things maybe need an update, whether it be the brain or the joystick or the motors. And this website will tell you how to do that. All right, good luck designing and building your robots and playing the game. And I hope you have a great time.